We'll be starting the session in another 4 to 5 minutes. Let other participants also join the session and then we'll start. So we are back after the break and now we will be heading towards the second session of our faculty development program. So without further delay, we'll just start the program. We are trying to make all the participants the coordinator. Please make a note of it. So if any of the participants have any doubts, kindly raise your hand by clicking on the option and ask the question in the chat box. So without further delay, today the speaker whom we have with us is Professor Indrajit Pan, who will be delivering his lecture today on blockchain-enabled IoT. Presently, Professor Indrajit Pan is working as professor in Department of Information Technology in RCC Institute of Information Technology. Dr. Pan is an academician and researcher who has made significant contributions in the field of information technology. His current research is focused on several cut-edging areas, including community detection, cloud computing, influence theory, and digital microfluidic biochips. Dr. Pan has also co-authored publications in reputable international journals, edited books, and conference proceedings. His valuable contributions also include editing research volumes and international conference proceedings. Among many awards, some of the prestigious awards owned by him includes India Prime Professor Award 2021 by Foxcluse, Young Professor of the Year 2021 awarded for excellence in teaching in Global Teaching Excellence Award Conference 2021, International Academic Leader of the Year 2022 awarded by I2OR in Global Edu Conclave 2022. He is also a senior member of the Institute of Electrical and Electronics Engineers and the Association for Computing Machinery, ACM. His research work has been recognized and published as patents, demonstrating his innovative thinking and problem-solving abilities. He has also served as a guest editor for the International Journal of Hybrid Intelligence, Indoscience, and is currently an esteemed editorial board member of Elsevier's Applied Soft Computing Journal. Sir, I would now request you to kindly start the session.
Thank you, Amrita, and thank you to all the organizers for giving me the opportunity to share some ideas within this session. And I'm currently switching off my video to maintain the bandwidth and trying to share my screen. Kindly give me a feedback once my screen is shared. Okay, welcome all the participants. Today is probably the third day, second session, and we are on the topic of secured e-healthcare system. Let us start. So this session is going to be on secured e-healthcare system, and we'll be talking about little bit of IoT and blockchain, and later on we'll be doing a case study in detailed discussion where we will see the integration of blockchain in the IoT module. So before I proceed, the main focus of this talk is to address one of the emerging issues with the healthcare industry. So we all know that healthcare industry nowadays, it deals with confidential patient data. And coming with the multi-facility hospitals, so there we get many facilities under one roof. May it be the outdoor service, may it be the laboratory services, imaging services, and different inpatient departments, and the operative cares, ICUs, and many other units. And not only this part of patient-centric things, apart from that, they have an admin part. So that admin part deals with the human resource data, mainly with the hospital staffs. And apart from that, they also deals with the patient data. And there we all know that from many years, it has been a practice for these multi-specialty hospitals or super specialty hospitals They maintains a patient unique ID, and under that, all kinds of health reports and the health activities, treatment process, whatever has been done under that particular unit or that particular hospitals, they try to maintain that. So we also need to concentrate on the huge patient data. And e-healthcare system in that way is trying to inject more and more data into the system. And there are many users, as we perceive, for this such e-healthcare system, involving doctors, nurse, hospital administration, and patient party as the major stakeholder. And they have different roles to be played under this e-healthcare system. Nowadays, even if we look into this, like from the outside of this hospital, we get like the facilities through the websites or mobile applications, where a patient from the outside of the hospital even can contribute to the significant part of the data, or they can access certain informations of this hospital system. Now, the basic challenge is preservation of the confidentiality and privacy of all these data. And these data are definitely, these are very sensitive data, and it becomes a duty of the hospital management also to maintain the confidentiality of all individual records. Now, if we look into the current research trend, we will see that they are slowly adapting a blockchain-based secure access for e-healthcare data. So today, we will initially talk about some of the preliminary basics, and then we'll see a brief case study where a blockchain-based solution has been provided on a proportion of e-healthcare data. It's not a whole segment, that's a huge application. So it works on a portion of e-healthcare data, and that's a real-time data captured captured from the inpatient uh, sections, and those are being how that can be managed. That one proposals are discussed in this way. So in today's presentation outline, we will see initially an overview of the case study, which we are going to discuss, and then we will perform certain preliminary discussion. I was talking about the current research trend. So current research trend, if we try to look out, like it's huge, and some of the major contributions I will try to discuss in 2 slides, and then we will be into the case study part. We'll see the motivation for behind the case study. We will try to formulate the problem, and I will discuss about the solution, and we'll show you certain experimental simulation. In this way, we will try to finish up today's discussion in this session. Now, advancement of Internet of Things sensors has enabled us to capture real-time health data from the patient body. And we know nowadays there are many IoT modules we can design, and some of them are also available in the market, through which we can capture real-time data from the patient health. And health data are stored under certain data repository of the e-healthcare system. And apart from these health-related data, e-healthcare system also stores patient personal identification information and billing-related data. And the various data, depending upon their nature, those are accessed. Some of them are accessed by the doctors, nurses. Some of them are accessed by the hospital admin. And a brief report part also goes to the patient party, who can track the progress of the treatment process of the patient. And certainly the system controls all these things through different access privilege, and we know that, like how to apply the access privileges and everything under a distributed system. Now, the major challenge, as we tried to address from the initial slide, is that the privacy preservation of all these records and secured access. With the introduction of the blockchain technology, the researchers are currently trying. It is not yet implemented practically in the hospitals or in the application in a full-fledged. Maybe in part somewhere it is being done, because there are many issues before a full-fledged application, practical application of blockchain technology in real field with the e-healthcare data. So the work is going on in many different directions. But blockchain technology has the power to provide these decentralized shared access and also the traceability, like who is changing the records at what time and how the things are modified, who is empowered to get the access of certain parts of the data and certain systems like that. So the case study that we will discuss maybe in the second half of this discussion or in the later part of this discussion, over there, we will see a IoT module has been designed. A very simple IoT module has been designed over there, which captures health data from the patient body, inpatient body, and all those data uh, captured from the patient body, different patient body with particular identification and timestamp. In this case study, will be initially transferred to an RDBMS module. The case study that we will discuss over there, we have initially used a MySQL schema over there, MySQL DBMS schema and database. And after that, that RDBMS information has been transferred to the MongoDB. So MongoDB, we all know that it supports the NoSQL structure. So sending or transferring the records from the MySQL schema to MongoDB, there we have a certain reasons to do that. And why not directly from the IoT module to MongoDB? There is also a specific reason which we tried to access in this case study that we will discuss at that point of time. And once the records are stored under this NoSQL platform, then through a blockchain-based uh, application, we try to provide access to the different users. And these users are, as we have discussed, we have considered like doctors, nursing staff, and patient party. And one more we can add, that is hospital admin time to time. So before we proceed to that case study, in some of the preliminary discussions. So initially, if we look into the IoT enabled system, so this is a kind of a concept diagram. For any IoT system, normally when we try to design for such cases or such case studies, we have three layers. So one part is dedicated for data collection, and the middle layer is dedicated to collect and transfer data, and another layer or the third layer is to analyze data and take certain actions. For the data collection part, if we look into, we have under the IoT modules, we can engage sensors, antenna, and different microcontrollers. So all these IoT devices, they try to capture data from various sources, and then we transfer them to IoT hub or IoT gateway. This is the communication section. And through that, after collating all the records captured from different sensors and devices, all are collated together, and then it comes to the third part for the analysis, where we have user interface, and that may be a human machine interaction through the smartphone or through the web browsers. We have certain applications developed over there, business applications, analytical applications. Those are basically CRM or ERP based operations. And we also have the backend systems where we mainly consider like different kinds of databases. Now, use of IoT in different industries nowadays are very much prominent, and one of the major presence of this IoT technology is in the healthcare sector. And apart from that healthcare sector, we have the power industry, education industry, pollution control, and many more. But These are the focus areas where we are trying to apply IoT in many sense. The key reasons behind the growing popularity of Internet of Things, the first thing is it is massively scalable. Through these IoT modules, we can capture many real-time data, and the IoT sensors are easy to implement in that sense. And with like it doesn't require a very high level expertise or programming skill over there. And sensors, depending upon its quality, it can be precise and efficient in operations. But before that, when we do the trials, normally at our laboratories, we initially start with the low cost sensors, and later on we can shift to the high end sensors when we look for the precisions and efficacies. And IoT devices, the power requirement is very less for most of the things, as because only it consumes power when it is active, and when it is in the sleep mode, like it is sitting idle, then it doesn't consume the power, much power from that. So apart from the direct power sources, easily we can design IoT module which can be battery operated, so battery can last long in such cases. And it has a intermittent connectivity in the sense only when it will transfer data, then only it will consume the network bandwidth, and at that point of time only it will consume the battery power. Otherwise, when the data is not being transferred, it can release the network bandwidth, and at the same time, when it is sitting in the sleep mode, the battery consumptions will be almost zero. And we can perform the technical optimization, as because uh, sensor data from different fields, once it is accepted through the programming platforms or through the computer interfaces, we can transfer them into the computer system, and we can easily apply or utilize those real-time data into the computer programs, and through the computer programs we can process them, analyze them in multiple ways as per our requirement. And always we can apply different optimization technique depending upon our requirement. And there are versatile range of sensors, so uh, many kind of data we can capture for multiple purposes. So definitely with this inception of IoT has improved the data collection technologies. However, uh, till now we were talking all goods about the IoT, but certainly there are a few challenges where the researchers are working now, at recent time, and many solutions are emerging out through these research articles. Now the question is, we have to look how far that is viable to be applied at practical fields. So first and foremost challenge about or regarding the IoT modules is the security, because we have to deal with multiple authentication processes while accessing certain units data and transferring that to different programming module or computer modules. We have to deal with security issues, and while applying multiple authentication processes over there, this challenge of maintaining the security of data is very much stiff, and always there is a possibility to get exposed of personal data. So care has to be taken while designing or dealing with the IoT modules in application level. Privacy is also a concern, because once your security is challenged, at the same time your personal informations which is transferring through the system can get exposed. So security and privacy is the foremost issue which always we need to take care of when dealing with the IoT modules for such sensitive purposes. And apart from that, we have two more challenges, that is the flexibility and complexity. So flexibility, often in the practical field, like the sensors individually, they can do the wonders. uh, very efficiently they can capture data, but when we try to integrate a diverse range of sciences together, then it is really challenging. And we need to look for the compatibility or the flexibility over there. And the complexity is like the managing the deployment and maintenance of particular module over there. So that was the part of basic part of IoT which we tried to discuss. And keeping in sense, we will be dealing the whole section in our case study module. I will show you that how we try to design a module initially with the low cost sensors, and later on for the precisions and something we tried to change some of the module. So since this is a case study, so it's not a foolproof system, but still we will show you a step-by-step process over there. And now on the other part, looking at the blockchain sections. So initially in the left-hand side, you can see it's a legacy system. So blockchain, very basic, very basic level, or at the primitive level, if we want to say, till now, there are three generations of blockchain: blockchain 1.0, blockchain 2.0, and blockchain 3.0. And coming to the blockchain 3.0, we can apply the blockchain for diverse application with the concept of blockchain 3.0. The initial blockchain was introduced upon the concept of bitcoins and everything. But anyway, it deals with the transactions related part. May it be mainly the data transactions. So in our legacy system where blockchain was not present, so it was a all connected network. So data can traverse from any point to any point, a complete connected network. So here you can see example of a banking solutions where at one end we have the bank records. Of this one end of the square, there we have the bank records, and other three ends consume two different parties, party A and party B. They are the customer of the bank, and in the other end we have the auditor's record. So when they interact, so it is quite understandable that the access privilege to the bank record which we have for any specific party, that is different for the auditors, and all are actually trying to deal with a similar record, whether bank. So ideally, the bank maintains a distributed DBMS or distributed data store. So when they try to perform any kind of operation, so any of the data store or from any particular location, they come into operations, and we get access from there, and subsequently the other stores are updated once changes are made. And coming into the shared ledger platform in the right side, what we have, so this middle layer, it contains all the data store, and over there we have an encrypted applications, which is specifically, we can say, a blockchain layer, and people are actually connected to the blockchain layer, and the blockchain maintains all the transactions through a signing or encryption. How it is done, that we will see in the coming slides. So normally when a transaction, this is a video which we love to put in, it is taken from the Edureka. So here, this is a process which it shows like how the chains, blocks are getting added into the chains, and how these blocks are formed, and that we will see in the later slides. But what happens that whenever there is a single transaction, with respect to that single transaction, a block is created, and that block is signed with cryptographic measures, and then that is added to the chain. And it has certain characteristics, like it is tamper proof. The person who has done this transaction, later on the party cannot deny that it was not done by him or her. So in many sense, all these transactions over there are quite secured. And as we can see, the blocks were adding in the previous slide. So blocks are normally formed one after another like this. So whenever we have there initially when there is no block, so a primary block is created, and after that, for every transactions with the initial transaction in the system, a primary block is created, and after that, with any transaction, a new block is added to that. And when a new block is added, so there are a couple of components. One component which is required, that is the hash of the previous block. And there is a transaction which is getting performed, for which the new block is being created. And the hash of the previous block and the transaction together is again hashed to create, and that is all together these three components are maintained in a single block. So this is an extended diagram, like some parties are making at a time, in a particular time it is making a single transactions, or there may be a combination of two transactions at any point of time. So whatever they are performing, all these transactions by any particular party at one point of time, all are taken into consideration with the hash of the previous block, and together they are again performed and with the cryptographic applications and nonce, they are hashed and a block is formed. Again, when we get into the next block, so you can see the block hash of the previous block, like in this case 15 block number 1574, hash of the previous block is taken into account in the next, during the next block formation. Along with that, a new transaction, together they are again hashed and a new block is formed. In this way, the chain grows. Now, if we look into the process of one particular block, so normally one of the very popular technique is over there is like Marklet rehash. So Marklet rehash, we are not going to discuss Marklet rehash algorithm today, but it is one of the popular mechanism which is applied when the hashing is done for construction of any particular block. The timestamp, that is also a very important information inside a block. The information of a previous block, this is actually the hash of the previous block. A nonce, this we know for any cryptographic application, this is a value we can adopt to apply any cryptographic hash technique. And this is a version info. Version info means some of the information related to that block. With that, this is an optional field. So mainly the hash of previous block, the timestamp of the current transaction, and this is the transaction which has been done at that moment of time. And upon that, we apply together a Markle hash to form a new block. And this particular component, so actually if we look into a single block of a blockchain, there are specifically two parts. As you can see in this diagram, the lower part is the transaction details, which actually is being performed on the shared ledger. And in the upper part, this is called the proof of work, or POW unit. So this proof of work, which is a kind of signature, you can say, we try to add on this set of transaction being performed at that particular timestamp. And once this transaction is performed with this signature, the things together forms a block, and that blocks get added to the chain. And in that way, the blockchain grows. So once we look into the requirement of a blockchain, so far we have seen how the blocks are getting added, or what are the components of the block. So once we try to work with the blockchain in the practical field, so we need these four major components to do that. The first thing is distributed shared ledger. So this is actually the data store, or where all the data are being maintained. Apart from that, we need a smart contract. So this smart contract is actually forms a logic. like how the transactions will be performed and what are the transactions permitted, who are the users with what kind of access privilege they have, on which data store or on which particular data field or schema they can work with, all these details and other norms. So this is a kind of, you can say, a kind of legal documentation for the blockchain, which is like say we say contracts. But why it is smart? Because it is written in the form of a program. So this smart contract is another requirement for the blockchain implementation. Requirement of cryptographic application is an inevitable part of these blockchain things, because these cryptographic applications, through these cryptographic applications, we can create the hashes or we can provide the signatures. And with these three, ultimately, whenever a block is added to the chain, so once added to the chain, so there a consensus, we say a consensus is formed. So this is consensus is a kind of agreement among all parties. So once a block is added to the chain, we run a consensus algorithm, so that like it is a kind of thing, a new a new unit or identity is being added into the family, and whether all family members are ready to accept that. In some of the blockchains, there are the provisions, a certain time span is given over there. When a new block is added following all these processes, we run a consensus algorithm over there. So consensus algorithm is like asking a final permission from majority of the stakeholders in the system, that whether they are going to accept the new transaction into the system or not. If anybody has any objection over there regarding a new addition of a new block, so this consensus algorithm, through this consensus algorithm, we can generate that objection. Now, different system has different policies of forming this consensus, and that policy of making consensus is written under the smart contract generally. So it may be something, be some of the system they go by the majority. If majority of the users or stakeholder into the system agrees to a particular block, then that is accepted. And what particular quantum, or rather what percentage of stakeholders is required to form the majority in terms of making consensus, that is also defined under smart contract over there into the system. So any parties or any stakeholder, when added to the system, they need to agree with the smart contract. Okay. And in some of the system, like the blockchain, specifically, there is another side like permissioned or permissionless blockchain. In permission blockchain, to some extent, but we can say the stakeholder addition can be done with due permission, and in permissionless, this is a kind of open blockchain. So in a closed network blockchain, where the number of stakeholders are limited or restricted to some sense, consensus algorithm can vary, and even over there, a single individual can raise a objection with certain transactions, and that has to be addressed. So all these logic we need to write under the smart contracts. The major benefits of the blockchain. So first of all is the reduced cost of overall transaction, and the transaction which we perform under the blockchain module, that is irrevocable. Like once done, we cannot revert back, or rather, if we talk about the consensus algorithm, then irrevocability says like once the consensus is made, after that you cannot discard a block from the chain. And until the consensus, in where the consensus algorithm has the importance, there always we can say until the consensus is made, we can always reverse a particular transaction. It is tamper resistance, means once a block is added with the certain details of the transaction, no one else can change or make any changes into that particular block or the details of the transactions. So nobody can tamper that. And consensus in variety of transactions, already we talked about the consensus in the previous slides. And we can store and define the tangible assets and transactions. So whatever is being performed inside the system, it is quite transparent to all the parties or all the stakeholders. Accuracy is high in the settlement of the transactions, because once a transaction is accepted into the chain, no one can deny that. So it is presumed to be accurate by all parties, and only then it is accepted into the chain. And it is effective overall for overall monitoring, that the challenges and the changes are less, and it is also easy to audit, as because once like a block of transaction is getting added through many consensus process, by auditing by the contracts, already it is getting added. So later on, when an overall auditing is performed through the chain of transactions, that process goes through quite easily. And this is the blockchain development part. So 3 generations already we are so far there. And blockchain 1.0, where we have bitcoins and programmable money. And then it was further evolved to blockchain 2.0, where we had Ethereum and smart contract. And blockchain 3.0 is for the non-financial uses. And when we had the blockchain 3.0 concept, then we tried to apply this blockchain 3.0 in different cloud related applications. We tried to apply blockchain 3.0 in different IoT modules, that may be in the agriculture sector, that may be in the healthcare sector, in different domains, that may be in the power sectors. So anywhere we have the application of IoT for the data security purpose, because if we look back our discussion so far, we have seen a challenge in the IoT in terms of security and privacy. We have seen an opportunity in the blockchain in terms of security and privacy. And there lies the scope of work, that whatever is the challenge in terms of IoT, the security and privacy, that challenge can be potentially addressed by the blockchain implementation. But yes, at the same time, there are many issues in blockchain implementation, and often we face those challenges to apply blockchain on certain platforms, and work is going on to overcome that. Now, if we look into the e-healthcare, this is to some extent a common term nowadays. So an e-healthcare, generally when it was conceptualized, so there was a patient and some attachable devices with the patient, like in terms of smartwatch. This is very common nowadays. Almost like if you see around the very high percentage of people are using smartwatches nowadays, and the smartphone also we can capture information. Now, the cloud, that is also a very popular technology in recent times, where we can store all these data in an effective manner. And later on, these information can be accessed by the doctors, the healthcare units, or by other parties. So this is the basic concept of e-healthcare system. This is an extended version of e-healthcare section, like we have the healthcare professionals, distributed section where we have the cloud services for data aggregation, processing, visualization, even some intelligent application with the knowledge extraction and dissemination. Some are even like the things like expert system or intelligent agent are also being included in this particular part. Uh, it also integrates with some external applications. There is a smartphone gateway through which it captures certain informations by IOMT devices. IOMT is a very common term. This is Internet of Medical Things, and through the IOMT devices it captures information, and these information initially either through a smartphone gateway or a cloud server or a fog server, it comes into the cloud storage. Even heterogeneous healthcare repositories at different healthcare units, they can transfer the information through a cloud server or a fog server into the cloud. And once it comes to the cloud, then all these cloud services comes into act, and there we can apply many data processing, data analytical application to process the data and information and ultimately distribute that among different parties for some effective utilization of that data. But what we are losing so far in the primary concept is that the maintenance of security and privacy of records. So far, if you look into this particular diagram, there is no such inherent security module included in this particular part. And we try to apply a layer over there, or rather the current researchers are trying to, one segment of researchers are trying to apply a layer over there, so that all these transactions which are being done for the well-being of the mankind, uh, it's okay, but the security of records need to be there. And also we need data to be transferred from the patient body through the gateway to the healthcare professional without any tampering, because we know the data related to different health measurement, data related to the laboratory tests, data related to the imaging service are very sensitive. If some way or other that gets tempered, if some way or other that gets modified in the process of transmission, then when that will reach to the healthcare professional, uh, that will be a misleading data, or that will be a misleading information, and that will in no way that will help the professionals, healthcare professionals, to diagnose the patient in a right direction. Always a wrong information will lead to a wrong diagnosis, and which will be very much fatal for the mankind. So the security and privacy of records is very much essential. Now, if we look into the current research trends, there are many research articles, but the case I am just going to present over here or discuss over here only 6 different articles, 3 in these slides and 3 in the next slide. So these are somehow chosen in a way which matches to my case study that I am going to present today. Apart from that, there are many related articles which you can find out for any of the journals in any journal databases, and you can, if you find interest, you can go through that. So the first work, which is related to some taxonomic review of use of IoT and blockchain in healthcare application. If we look into the key contribution of this work, it discusses about different healthcare applications that integrate IoT and blockchain, and focuses on application and challenges associated with its implementation. So the major findings from our end from this particular article is that we get the direction to possible researches to improve healthcare application. And also we get hint of using artificial intelligence, big data, fog computing, and cloud computing in the healthcare domain. The next work is on framework for healthcare based on cloud computing and IoT application. This is also a 2022 publication. And this is they have discussed a case study on e-health smart network infrastructure. And they have also analyzed the impact of IoT in combination with cloud computing. Actually, when we try to capture data from different sources to the IoT sensor, the volume of data is increasing, rapidly increasing, or it is multiplying in a rapid rate. So the storage, or rather better to say the efficient storage of those records, is a major concern. And parallelly with the development of the cloud technology or the cloud framework, that is a benefit, or that is an opportunity to us, that somewhere or other we can find a effective mechanism to transfer all these information for effective information into the cloud storage, so that storage in a large sense does not arise as a major issue. And from this particular work, our learning is a framework that uses IoT sensor to capture health data, and they also deploys wireless sensor network for data transmission. So people who are working in the domain of wireless sensor network, they can also gain interest to contribute in this particular domain. People who are working in artificial intelligence, big data, or cloud computing domain, they have the scope to contribute in this particular domain, because there are many open scope to work in this. And the third work is on blockchain technology in the future of healthcare. Here, basically, the key contribution of this particular article is the uh, i- injecting safety and security in the information related to electronic diagnosis, and transforming blockchain into the form of crypto. Means transforming blockchain from cryptocurrency to the medical industry. So that is actually getting transferred. Like initially we see the blockchain 1.0 or 2.0, that was mostly concentrated on uh, financial transactions, financial related aspect, cryptocurrencies and everything, bitcoins and cryptocurrencies and everything. But whenever we come to the blockchain 3.0, so this is like blockchain is getting applied for the general field. So here in this particular work, the most effective one which we find is that there are numerous use cases of blockchain in the healthcare industry. So this work presents multiple examples where blockchains can be potentially or effectively used in the healthcare industry. And they also drew a strategic relation between blockchain and intelligent health, and also discussed about the obstacles of integrating blockchain in the healthcare application. Certainly, there are obstacles. So before you do something, you need to learn about the challenges so that you can plan your solution in that way. Now, coming to the fourth work, this is a data minimization technique in blockchain-based healthcare. So the key contribution of this work is to restrict the data collection to introduce data minimization. So actually, when we collect data or information through an IoT sensor or from any particular real-time data from any particular sources, along with the required information, we get many such other attributed information over there which may not be of that much use for us. So we need to refine that. And so that you one way was one concept was already there, like you collect data and then you prepare the data for your further analytics and application. uh, but uh, at the same time, the basic challenge is that when if you gather so many information, so one way that is consuming more power and bandwidth in terms of means from the end of IoT module to transfer so many unwanted data or information into the system. And the next thing is, when it comes to your system, you need to spend time to get your data ready for subsequent application and analysis. So in one way, this work proposes a technique where only the effective information can be gathered or collected from the sources. And also since the blockchain is new, many people are concerned about the use of blockchain, because till today, most of the industries in the practical field, they do not rely in a full-fledged manner upon the blockchain, that how much effective it would be. Rather, they rely on to stay back with the legacy system, like that distributed databases and everything with that, and the application generated on that, they are quite happy with all the security measures and other aspects available over there to maintain the security and privacy of their record. So till today, the popularity of blockchain is not much. Only only among the academicians or among the researchers, people who find interest on blockchain, they know the term or the details about the blockchain, how it works or how it can be, or they have the basic idea. But how much effective it would be for other applications other than cryptocurrencies and all, so that is not well accepted till today. So this much, so this particular area is quite open for advancement of research and everything. So from this article, we find how the data minimization and classification can be done, uh, targeting towards the data processing. And we also get an unique idea of data minimization from the data custodian's view or data owner's angle. The third work, this is a systematic literature review on prototyping with Arduino. This shows like the application of an Arduino board and IoT module, how to design a segment, a prototype design, how it has been done, along with the intensive analysis and study of how to work with the Arduino. And mainly from here, we have learned like how to use Arduino in system design to make it cost effective and scalable. And the last one is on blockchains to digitalized healthcare services by designing a distributed electronic health record ecosystem. So this is also deals with the digital transformation of the healthcare sector through blockchain. And this also deals with the distributed electronic health record maintenance through private and permission blockchain. And we see the results like better clinical outcome, reduced medical error, and improved organizational outcome. So certainly, we from this particular article, we realize that if the blockchain is maintained and if the blockchain is applied along with the e-healthcare system, so not only it takes care of the security and privacy of our record, but the way it is implemented over there, the way the transactions are performed under the blockchain, so always we can expect that the transactions will be more precise and accurate, and in that way the medical errors will be reduced, like the data will be more secure, that will be transferred more accurately in a and briefly the to the point records will be available to the parties, and that will help to make better clinical diagnosis. And also the overall administrative control of the system will be an effective one. Now, before before coming to this case study part, so all the preliminary required discussions we have made so far. Uh, if you have any questions, we can take at this point before we move to the case study section. Is there any questions so far? Okay, so let us move to the case study. And this is a blockchain enabled e-healthcare system. So how we have designed this particular module and how tried to give one angle of solution to this, that we will discuss in this particular section. So the motivation behind identifying this problem as a case study is that we have seen that legacy system always struggles to manage large volume of healthcare data. One of the major challenges that IT infrastructure cost is very high in the legacy system. And also we have locational threat to store data in a single site. So we have to move for, or we have to think for a distributed storage of data for the healthcare industry, and for many, or for say most of the uh, hospitals, it is a little difficult and cost consuming to maintain the huge volume of data on a distributed site. And we have seen that there is a challenge for privacy preservation of sensitive data, and single system administrator based management of e-healthcare system may also suffer from the issue of trust. So normally when there is a system administrator based application, uh, every parties may not rely upon that system administrator, and there are many instances where sensitive data has been compromised from the end of system administrator. Sensitive access privileges has been compromised from the end of system administrator. So in that way, we can do something different to inculcate more trust in the e-healthcare system. Now, looking at the technologies like Internet of Things, cloud technology, and the NoSQL database, in this case, we have used a MongoDB platform and the blockchain technology. This solution has been conceptualized, or the problem has been conceptualized initially into the three phases. So there we will have an IoT module, a small IoT module to capture some of the real-time health data. So these, as I see, to small unit because it is capturing only 2-3 attributes of health-related measurements. Now the next we will discuss how to transfer this data into a NoSQL platform, and why to transfer into a NoSQL platform. And finally, a blockchain platform for shared dissemination of data through log-based user access. So this log-based user access is an inherent property of the blockchain platform, and it maintains the traceability of all the transactions which are performed under this particular platform. Now, solution for this case study of the concept model will capture real-time health data through IoT module and will transfer it to the NoSQL database. A broad level diagram we have seen at the beginning for this particular case study, where we have seen that the data is being initially captured from the inpatient body by the IoT module, and then through a computer program, the data is being processed and transferred into an RDBMS schema or into an RDBMS database. In this case, we have used MySQL. And from the MySQL, we transferred it subsequently to the NoSQL platform. And for the NoSQL, we have used their MongoDB platform, and then a blockchain application to records all the user by user transactions, or all the transactions in a chain. So for the solution that we derive for this particular case study, it is splitted into three phases. In the phase one, we will talk about IoT module for real-time health data capturing. In the phase two, we will talk about transferring the captured data to NoSQL MongoDB storage. And in the phase three, we will talk about blockchain implementation for secured and conservative access. So in this solution, in the phase one, which is associated with the IoT module designed to capture the body temperature and pulse, So initially, two sensors were used with the Arduino integration. So there was Arduino board and two sensors. One is the LM35, very common to all of you. You all know the LM35 sensor. It is a temperature sensor, and it has like three legs, as you can see in the diagram, 1, 2, and 3. So one is the power supply, one is the ground, and another one is the outline. And we have also a pulse sensor which can sense like the pulse BPM. Okay, so this was the primary circuit design. As you can see, a very simple circuit diagram. This is the Arduino board, and these sensors, two sensors are connected in the breadboard, and then they are connected. This is the actual circuit diagram which have been implemented in the right hand side. You can see the picture. So this is the circuit diagram of the first model, and in the Arduino board, this was the USB and power data. So through this cable, actually, those who are familiar with the IoT, this is very common and very simple thing to them. So this is, we supply the power to the board, and also whatever the data is being captured, so through the communication port we capture into the programming module. So this is the LM35 sensor connected over there into the analog input channel, and this is the pulse sensor that is also connected to the analog input channel A0 and LM35 to A1. And this is the powertrain of the Arduino module, and the rest of the lines, how it is connected, you can see from this diagram. But the initial module, we had the issues of precision. As I said already to you in the very beginning, that sometimes precision and accuracy is a challenge for the IoT module. And one of the major reason is the quality of sensors that we use over there. So with the change of sensors and change of the microcontroller, sometimes we get the faster access, and we can capture the data in a more efficient manner. So once we tried to change, a couple of things were introduced over there. So one of the major changes that we did over there, that is, we introduced ESP32 microcontroller in place of the Arduino, because of the better memory capacity and better accuracy also. And we used MAX 30100 sensors, which can measure BPM and SPO2 both. We have gone yet with LM35 as a temperature sensor. And one new module we have attached over here, that is RC522. You all know that this RC522 is a RFID module, and the basic requirement for attaching RC522 is that to identify the patient. So it was something like patient will have an RFID card with its identification, the inpatient. So whenever the data will be captured, so along with the patient identification data, data will be captured from the system, and whenever it will come to the data store, that patient identification information will also come along with the records, different temperature records, BPM records, and SPO2 records. So this is the revised circuit diagram, and this is the circuit which was fabricated on a blank PCB board. So this is like the new microcontroller. An LED module initially we have attached, later on it was replaced. This is MAX 30100 sensors, and this is the RFID module RC522 attached over there. So through this, actually we can capture BPM, SPO2, and temperature. These three things with the patient identification data. So this module was capable of capturing all these records. In the result sections, I will show you how data was being received at our end. Now in the phase 2, so initially we have used a Python program to transfer the data captured in a text file to MySQL schema. In the MySQL schema, we had a couple of schema or tables over there. So this is, we haven't shown you all the tables. So mainly this is the table which is meant to store the patient record, And briefly, as I already told you, this is a very small system, so only we kept like the patient ID as a primary key along with the time, because for the same patient ID we can capture multiple records at different time interval. So this is the time, so this time is the default value, is the current timestamp, and we capture three information related to the patient through our sensor, that is the temperature, BPM and SpO2. Now, to transfer the data to a NoSQL or MongoDB storage, we have used again a Python DB API and MySQL connector for the Python. So in one way, we have a Python application, PyCharm, and in another way, we have the MySQL. So using the MySQL connector, we try to establish the connection, and the connection request is sent to the MySQL. And once the connection request is approved, cursor is sent back, and with respect to the cursor, we try to execute the query, and whatever the data we captured in the text file, that data is transferred into the MySQL schema. So this is a very simple process. Anyone from the computer science background, they are quite familiar with writing such programs with the help of Python. Now, actually, our, since like the data volume is quite huge, so always it is suggested that we can go for the cloud storage, because in a distributed storage or in a database server, own database server, if someone attempts to store the records of a healthcare industry, that is not at all suggestible. In our case study, the volume of data is quite less, so we could have done it easily in a standalone system. We have installed the MySQL things, and in another way we have installed MongoDB and tried to work with that. But actually, for a practical application, this has to be done on a cloud storage. And if you do some of the literature studies extensively, you will see that the cloud data store supports NoSQL structure. So that's why in our simulation process also, we tried to see how the things can be done from a NoSQL structure. Now, in the NoSQL structure, when we try to store data, we know that we have a fancy to store data in any particular form, and there is no such major restrictions over there, like the restrictions we need to maintain in the RDBMS module. So in this case, we tried to do that whatever the data we captured in a text file, we could have directly transferred the data into the MongoDB storage. But to some extent, we felt that might lacks the support of storing data in a structured manner. So that is why the only reason what we thought of in our solution, that it will be better from the text file if we transfer the data into the MySQL. So automatically it will be structurized in a schema, and after that from the MySQL, if we transfer to the NoSQL storage, so that kind of structure will be maintained under MongoDB. So with that essence, this is a trial only. Maybe we can put a second thought, or there is always a scope for discussion over there. So this is what we tried to do. We tried to establish a MongoDB connections with the SQL connections, and collect the list of tables from the SQLs. We collected the data from the table and inserted into MongoDB. So all the information which primarily were captured in MySQL tables, so ultimately that was transferred into the MongoDB. And finally, in the phase 3, we have the blockchain information implementation on the MongoDB schema or on the MongoDB storage. We all know by now that blockchain provides a shared and immutable ledger. And this is actually the principal workflow of the blockchain. We have seen before in the earlier preliminary discussion that whenever we try to form a block, So it always refer to the hash of previous block and the transactions in the current block. So hash of previous block is along with the transaction of the current block is again hashed to form a new block. So this way the blocks are added. This is just a kind of recapitulation because already we have seen earlier that how a new block is added. So any block, again I am repeating, it needs to have the hash of previous block apart from until and unless it's a uh, preliminary block. After the preliminary block, every block they need to have the hash information of the previous block, the current transactions for which the block is being created, and together another hash is applied on that. And Markle hash algorithm is so far one of the popular algorithms so far being used. Maybe in the coming days some other algorithms can be introduced in order to hash a new block over there. So the new block which is being added, it has three component: preceding hash, data part is the transactional data, and hash which is generated by applying some simple hash algorithms. Okay, so the centralized blockchain model which we tried to design so far is like in one way we have the administrators, then there is a control, and this is the block code health database which we try to maintain in the MongoDB. And on that MongoDB, we have implemented the blockchain, and there is a like the operational data. We have several parties, they are dealing with the operational data, and access to the MongoDB data store or access of the MongoDB data store to the stakeholders in terms of doctor, nurse, or healthcare executive or patient party over here is being shared by the privileges of the blockchain. As we said, the smart contract over there, accordingly, it will work in that sense. Now, uh, how this blockchain implementation for secured and conservative access works. So actually we for the centralized we try to implement a centralized blockchain for this smaller application, and mainly we use Node.js and MongoDB engine to implement the blockchain module over here. And here is the actually the workflow of the single block. So initially it checks whether there is a genesis block or not. So the very initial block or the first block of the blockchain is called the genesis block. So if the genesis block is not present, so this algorithm will create the genesis block. Otherwise, if the genesis block is present, then it will look into the new transactional data. So new transactional data means it will allow the new transaction. And once the transaction is performed, and it will also refer to the hash of the previous block. Already we have seen that. And we run the POW algorithm, which is the proof of work algorithm, to generate the hash of the current block. And once the proof of work algorithm, this is specifically a kind of simple hash algorithms we apply over there. And once that is applied and the new block is hashed, so that block is added to the chain, and this particular transaction is completed over there. So this is how a single block is added to the chain, and multiple times the same task has to be repeated when we go for a new transaction. So any new in this particular healthcare system, anytime a new record is being added, so that is that will be a transaction. Anytime a new record is fetched to make some diagnosis, that is a kind of reading transaction. Any means after looking at the records, if doctors provides a prescription, or maybe healthcare associates like nurse or attendant, they update any record into the total treatment process, so everything will be considered as a transaction over here. And every time this particular flow will be maintained to add a chain into the block over there, to add a block into the chain over there. So this is a detailed algorithm which I discussed in the previous flow diagram. And now coming to the simulation part. So this is the comport reading. You can see the finger is detected on the sensor. This is the identification of the RFID module, and now the details are coming, like what is the heart rate and SpO2. So that these details are coming over here, and multiple time these records we can read from the uh, comport, and we have closed down the timestamp over here. We have not ticked the timestamp. If we check the timestamp over here, so at which time this is being written, this data is being read, so that details also will appear over here. And this is the time when the access is denied. So actually we kept, for the testing we kept two card. One card was validated, so this is with the validated card, so the access was authorized over there. And if the card is not validated, so from anyone else, at that point of time the access will be denied and no records will appear over there. So this is one blink dashboard we did to check the reading and to check the compatibility of reading with what data we were receiving from the comport, and whether that was in the same way it was coming over there or not. So that was the kind of cross validation we did. But this blink dashboard doesn't have mandatory resemblance with our workflow over here. So it is a kind of auxiliary testing we did over there, so we kept it for presenting over here. Now this is how we did the MySQL schema, and this is, you can see the data view of the schema. So when we through the program we tried to transfer the records, so this is how the patient IDs are getting recorded, and this is the temperature of different patient, ppm, SpO2, and this is the timestamp recording, like for the same patient ID at what time we are getting all these records. And after that, means this is the MySQL schema view. And after that, when we try to do transfer all these record into the MongoDB storage, this is the view of the MongoDB storage, like how we can transfer the same thing into the MongoDB storage. And over there, in a dictionary like structure, you can see with the attributes, the values, the same values are getting stored in the MongoDB storage over there. So this is the overall process up to the MongoDB storage, how we have viewed over there. And the transactional screenshot I cannot show you at this moment, but the later on any kind of transactions which we tried to perform, that was performed through the blockchain module. Okay, so coming to the end, what we see, the health record of the patient under any healthcare organizations are growing day by day, and almost in an exponential rate. So data maintenance is really a challenge. And moreover, all these records are sensitive and it demands privacy preservation. So for that, not only the designing of effective devices for collecting records, but also we need to focus on maintaining the privacy and sensitivity of the records. So we presented a case study which captures a real-time health data to an IoT module and transfer the captured data into the database. And overall solutions provides a clear insight about the secure data maintenance through blockchain implementation on MongoDB for e-healthcare data. So these are a couple of references which I tried to follow while preparing this particular presentation. Okay, and that was all from my end for this particular session. And now I am open to questions. If you have any questions, I'll be happy to answer.
Hello, sir.
Yes.
Sir, if we would like to connect many sensors,
Hmm.
is it possible to connect with a single Arduino or any other power sources or relay is required, and
No,
how to use that?
probably that I have said as a challenge in one of the slide, that integration of multiple sensors through a single ESP32 or Arduino is difficult. Okay,
Okay, then.
so that's a challenge,
Hmm.
and that particular aspect I have told in that particular challenge slide of IoT that
Means sir,
if we
I am not asking for many, means 100 or 1,000, not
hmm,
like that. If I have to like to connect
like
10 or 15.
10 or 15, yeah, I understand that. So in that case, how to integrate, there can be many possible ways. Okay,
Yes, yes.
so the pins are limited in whether you say Arduino or ESP32 pins are limited,
Hmm.
so definitely you cannot engage multiple sensors in restricted number of pins. But what you can do,
Hmm.
parallelly you can run two parallel devices, and through two different COM ports you can access through your programs. Like you can engage two parallel ESP32 devices through two different systems. You can capture data, and then after once the data is captured into your computer system, after that you can integrate. That is one way. We have seen one solution, but we haven't tried that. So that
Okay.
is an open scope of work over there.
Means
Okay.
sir, and if the systems are, means if the sensors are multimodal, then also it is possible, na?
Yeah, if the sensors are multimodal, then always it is possible.
It is
Okay.
possible.
Hmm.
Okay. So sir, is there any circuit diagram for that? Means
Right
could you
now,
please?
yeah, right now I do not have any such circuit diagram.
Means sir, I
Maybe-
will then I so that I will contact you later, sir. No problem.
Yeah, always you can.
Okay, sir. Thank you, sir.
Hmm.
So thank you, sir, for your valuable speech. I think it will help us a lot to how to connect the sensor, and as well as how to use the IoT system in the healthcare.
Okay, I thank
So
all the
thank you, sir.
organizers
But
and
sir,
participants for giving me the platform to share some of the ideas. Thank you very much.